Hello and welcome to the Engerati studio here at Itron Utility Week. I'm joined now by Wes Sylvester, who's the Director of Energy and Transportation at Cisco. First of all, welcome.
Thanks, glad to be here.
Thanks for making the time.
Yeah.
We're at the end of the day, which seems somewhat opportune because I've done a lot of the interviews, and by and large, what is really interesting this year is we're talking more and more about data. The sensor conversation is going down the road of, well, those things are going down to a zero-cost space almost, right? Exaggerating a little bit, but it's all about the data. And we're talking off air a little bit, and on that note, Cisco is doing some interesting things around the data management piece. So can you just tell us a little bit about what you're doing and how your view is in terms of the data management side of things?
Yeah, absolutely. So there are so many sensors and devices creating all of the data that everyone knows about. That's table stakes at this point. Everyone knows that. And then there are also companies that are doing a lot of analytics on some of the data if they can get access to it. But where we spend a lot of our time lately is on the management of the data. And so creating the ability to run applications at the edge so that people can maybe do some optimization of the data closer to the edge. They don't have to send it all back over a single bandwidth, and then being able to send it to multiple places so that it can go to different applications instead of back through a single head-end application and then have to be distributed.
So the net result of that is you're only pulling back the data that has the value.
That's right, yeah. We can either pull back the data that has the value, or better yet, we can actually enable vendors like Itron to run an application of their own at the edge in our network. So we can create a container.
So they're the ones who do the analytics?
Yes. In many cases, the partners in our ecosystem would do the actual analytics. We could create a container at the edge using our Kinetic platform for them to run their application that would have something very specific to energy, for example. So Itron is going to know more about energy and energy management and meter data management than Cisco will. So why not create the place for Itron to run that application at the edge? And so that's a big part of what our Kinetic platform does.
And then the obvious business benefit is that you are not pulling as much data back. But I would imagine that there is another business benefit that by being able to analyze at the edge, at the container level, you can maybe be speedier in terms of how you push the relevant actions around, because we're all talking about predictive intelligence at the edge.
That's exactly right. Yep, that's exactly right. So we can reduce the amount of data, which is typically very valuable for a low bandwidth, low latency type network. But we can also, if they do some of that analytics at the edge, they can do more decision making at the edge as well. So the application could talk to another application, maybe an application out on a home or business could talk to a substation, and that decision could be made in the field more locally. The other thing that's significantly valuable is that the information can go to different places. So previously, you may have meter information that has to go back through a central location and then be shared before it can be analyzed. By then, the decision might be too late. And so if we can do it closer to the edge and then send it 5 different places at once, then all of those applications can make decisions together and make the application run more smoothly and quickly.
Because look, at the end of the day, the reason why this edge intelligence needs to be take place is because the grid edge is getting much more active,
right?
And we all know that. But also within that, what you just alluded to, the speed at which that needs to happen. You're talking a sub-second latency, aren't you? Effectively, where
that's
we
right.
need to get to.
That's essentially that's exactly right. So even if it's things like distributed generation, rooftop solar, that may be capable to be managed at a certain level of scale when it all comes back to a central management function. But when we get to places where it's pervasive and everyone has rooftop solar, and then people start adding things like energy storage, and there's community storage and grid scale storage, all of these things have to play and interoperate with each other in a very quick fashion. And so being able to do more of that at the edge, it also reduces the processing power. So if we have to take millions of endpoints back to a central location, the processing power required to crunch those millions of endpoints is much higher than if we can crunch 1,000 endpoints close to the edge and make good decisions out at the edge.
And how do those applications get sent down to the container? I mean, are they literally like, everybody's talking about robotics in the sense of software robotics.
Yep.
Is it that sort of use case? You send a bot down and it crunches numbers? And
it's almost like it's almost like a secure app store in a way, right? Just like we use app stores or the Play Store on either your Android or Apple phone, there would be an app store that could manage those applications at the edge, and it would help keep them updated. So if there's an app running in a container on 600 routers at the edge, there would be a centralized management to be able to update, upgrade, and manage the security of those as well. So exchange security keys, make sure that that application should be talking to a piece of infrastructure that it's trying to talk to, all of those things that everyone would be concerned about when it comes to security.
And what's the sort of order of magnitude? Because it's one of the things that we've written about with smart meters, and I only use this as an analogy, just to bring it to life. Is like, within a router, there's a certain amount of space. You need firmware updates and all that sort of stuff. So do you guys handle all of that, and then literally the customer, someone like an Itron, is just concerned with writing the application, getting it validated, and then it works?
That's right. Yeah. So we parse out a piece of the router, parse out a piece of the processor within the router to be able to run that application, and then we provide all that information to app providers and say, this is the space that you've got, this is the memory you've got, this is the accessibility you've got, and then they can write all of that. So it's openly available. One of the key tenets of Cisco ever since we've come into fruition is open, interoperable, standards-based, and so we're pushing very hard around Wi-Sun Alliance and things like that. So having everything application-based be standards-based as well is a place that we're very focused. But yes, we would create all of the kind of the parameters around which they could write the app, but then the specialty of writing the app, because it's it's a very specific knowledge, would be written by specialty vendors like Itron.
And you talk about the edge and containers at the edge and open standards. Does that then also allow you to, almost interplay with the edge devices that are coming on stream? Because we've just been talking about the obvious ones. No one knows what's going to happen in the future. You're going to have smart inverters. You're going to have voltage regulators. So all of that can plug into the system.
Yeah, that's the idea, is that if we stay focused on standards, that we will be able to more easily interoperate the what might come. And that's the way we've always done it. Even if you look at traditional video, we could have easily created a very specific proprietary video protocol, but things like YouTube and the way we deal with video on the internet today on a regular basis never would have developed, which creates a massive marketplace for everyone to play in if you create a standard. So we focused on standards in video, so we're having the same focus on standards when it comes to the grid.
And are you then applying that same standards-based model into the applications, or is that now getting a little bit more into a proprietary area?
So the application itself, we typically won't write the specific application. So the container that we create, the container we create and the secure place for that application to run is definitely based on standards.
Right.
The application itself, we are typically working with partners who are standards-based focused. So we like to have people in our Cisco developer network who speak and focus on standards-based applications. So Itron is a strong partner for us in the Wi-Sun Alliance. So we don't necessarily have a number of partners in our CDN, which is the Cisco Developer Network, that aren't standards-based and focused. So it's a focus, but clearly, those people are writing the apps, so we won't be controlling them on how they write their apps.
Sure. And is this already live in the field? Have you simulated use cases? I mean, if you turn it back to, let's say, a utility that's watching it, and we want to try and articulate the value. I mean, some of it is very obvious value, but can you draw out some more nuanced value that a utility could get out of that? I mean,
sure.
Based on your previous life's experience as well, right?
Yeah, we've done some very basic applications, and we've done some more advanced applications. Just a basic application that I think provides a significant amount of value is one where an application could run at the edge in this container that looks at, let's say, 2,500 meter values, and you're running a volt-var control program, and what you really need to know when you're running a volt-var control program is where is the lowest voltage meter and where is the highest voltage meter. You're getting 2,500 meter endpoints back, say, every 5 minutes. You don't really need all of that data. So using this container at the edge, we write an application that can analyze all 2,500 endpoints and only send you back the highest and lowest. So every 5 minutes, you go from 2,500 data points to 2 data points. It's a significant value from just throughput standpoint.
You can really quickly laser in and say, that's
then,
a problem.
Instead of getting the 2,500 back and then having to figure it out, you very quickly get back maybe a location and know right where the issue is or right where your lowest voltage is.
And, you know, it's my observation, so this is entirely my comment. I get a sense that there are a lot of utilities and DSOs, and, you know, I talk to quite a lot in Europe as well, where this notion of edge control is one that is either being piloted or theoretical. You know, how long do you think it'll take this industry to start putting it into the field? You know, where are we with that sort of tipping point?
Yeah, I think doing the data management in the field is already happening. So if I just expand on that example I just gave, that information is valuable not only to the meter data management system, because it might be able to do some volt-var applications, but you also might need that information into a distribution management system, your DMS, your volt-var optimization system. So that edge system is also capable, because we're using IP networks now, to send that information not back to that single location, but to both locations at once. So then, even if the decision making or the action that is required in the grid is happening at a central location via a DMS, the information doesn't have to go from the edge to the meter data management system, to the distribution management system, do some analysis, make some decisions, and then back out. It can go straight to the distribution management system so it can make that decision quicker. So I guess even if the automation itself doesn't quite get to the edge yet, the speed of getting the data back by doing some of the application and analysis at the edge is significantly valuable.
And I'm just getting in the corner of my eye some waves in terms of we're sort of coming to the end of our time here. But does that then also lay the platform for, you know, some of the other people sitting in here, and we've been writing about it for a long time, is this smart city concept, and let me bring it down a little bit more. It's more about all these different networks now starting to interplay, not just the energy network, but the municipal network and all that. It must make all of that, it must be a key enabler to all of that, so that signals from this network can go here a little bit better as well.
Absolutely. So that's a key enabler to doing things like a smart city, where a utility might be the service provider that creates the network, that then reads meters for a water meter or tells a garbage can that it's full and sends that information to route the garbage truck, or reroutes stoplights and control systems for ambulances and fire and emergency services. So all of that can interplay quite well, and the ability to segment at the edge and put things into segmentation securely, so that the information that the EMS system might use or get, even though it's operated by a utility, the utility doesn't necessarily get access to and control that information. So it can be routed directly to the EMS system instead of having to come through a central utility head end. It's a huge enabler for the utility to do more than just be a utility provider.
And just a last question to you, because I know you, Cisco, are always looking ahead. That's how you've stayed in existence.
Always try and see around corners. We're doing our best.
Yeah. What are you seeing? I mean, you know, is this real? Because I've been commentating on digital cities and smart cities for a long time. We used to call them digital cities, and before that, something else. But I get a sense that we really are at the tipping point, because the energy systems have finally adopted IP as a network, so there's less of that protocol war stuff going on, and we're getting closer and closer to try and collide all that data. Are you guys seeing that as well? Would you?
Definitely.
Yeah.
So we're talking with a number of customers globally, both in the U.S., in Europe, in Asia-Pac, about how do those networks interplay with each other. And if you look at the latest research, I think Cisco was named the leader in smart cities implementations. We've already been doing some of those smart cities implementations, and the exciting part is that we're starting now to take what a city might have implemented from public service Wi-Fi or from routing of traffic optimization, and now integrate it with energy and control systems data so that buildings can become smart and interact with the grid itself, which before those were kind of never the twain shall meet, right? It was buildings were managing over here, energy were over here, and they were working against each other. We're finding ways for them to integrate with each other and work through the city system. So absolutely, I think it's on the verge of really getting big.
I mean, even your job title alludes to that, right? You're Director of Energy and Transportation.
We're seeing such a convergence of the two that, I don't think that energy, 10 years ago they wouldn't have said energy and transportation should be so close, but you're absolutely right. Yep, good play.
That's perfect. On that note, we'll leave it. Thanks ever so much for joining us. It's been a pleasure talking to you.
Thank you.
Thank you as well for watching.